Hello, ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today we're going to be looking at how you draw molecular structures for polyatomic ions. So follow along in your notes. If you have any questions, you can ask in class. So we talked about how to draw Lewis dot structures, but specifically we were looking at just, regular old molecules and not polyatomic ions. So the nice thing is if you know how to draw if you know how to draw Lewis dot structures for regular molecules, polyatomic ions are basically the same. Um, in fact, the only difference, obviously, is that polyatomic ions have charges to them. And so if you have a cation, you're going to be losing electrons. So that means you're going to need to subtract electrons from your total. So for example, if you have like H3O, if we were to add up all of the electrons in H3O, we have 3 from the H's and we have 6 from the oxygen. So 3 plus 6 would give us 9 electrons, but H3O doesn't exist. What does exist is H3O plus. So what do? We take our 9 electrons, and since we have a positive charge, we subtract 1 because it's a plus 1 ion. And now we have an octet, we have 8. For anions, on the other hand, you have gained electrons, right? Anions are negatively charged, so that means you're going to need to add electrons to your total. So if we have SO4, again, sulfur, that's 6. Oxygen's also 6, but I have 4 of them, so I have 24 just from the oxygens alone. So if I were to add that up, I would get 30 electrons. But SO4 doesn't exist. What does exist is SO4 2-. That's the sulfate anion. And if you add an extra 2 electrons to it, you get 32, which incidentally is a multiple of 8, another octet. Okay, so another kind of key, if you want to call it that, to how we identify polyatomic ions in Lewis dot structure form is you always put a bracket around them, and you always put the charge in the upper right-hand corner. So for example, this could be a generic, well, I guess let's make it sulfate. So if that was an S, X can be anything, but let's say that's S. To show that I did not just kind of have the right number of electrons, but instead I had to add or subtract, I put brackets around the entire structure, and then however many I added or subtracted, I put here, okay? And so that kind of gives everybody a clue. That's what's going on when you see brackets around a structure. Now, what about this? So if we have these three, let's see if we can figure out how to draw the Lewis dot structures for them. So I have ammonium. Remember, you have your polyatomic ion chart. Ammonium is NH4. If you didn't know that, you could look it up. Now let's add together our electrons. So how many do I have from nitrogen? I have 5. How many do I have from my hydrogens? I have 4, but I have a positive here. I have a plus, a cation. So what do I do in that situation? I've lost a single electron, so I subtract 1. So 5 plus 4 minus 1 gives us 8. What's my central atom? Obviously, it's the nitrogen. I can draw single bonds going out, and then I count my electrons. So I have 2, 4, 6, 8. These have duets. This has an octet. Notice I put brackets around it, and I have my positive charge. That is the correct Lewis dot structure for ammonium. What about the azide ion? Notice I gave you the formula because that's not on your formula page. How many electrons do we have? Well, I have 15 just from these nitrogens because nitrogen is 5. I have a negative ion or negative here, so that means that I add an electron. So if I add an electron, that means I have 16. What's my central atom? Well, that's kind of cheating, right? Obviously, it's nitrogen. I can draw single bonds to start with and then start putting my electrons around the outer atoms. Now, here is your chance. See if you can draw the correct Lewis dot structure for this, and I'm going to give you choices, and we'll see if you can guess which one is the correct one. I have A, B, C, D, E. So try drawing it, and then take a look at these. Which one of them matches the one you drew? All right, correct answer. A. You should have 2 double bonds, and then you have your lone pairs of electrons. Is there another structure that works? There is. I mean, you could have a triple bond on one side and a single bond on the other side. That's also allowable, but it's not exactly a common way of drawing that structure, but it's possible, okay? But these are not possible, and they are not allowed under the rules of Lewis dot structure. So if you drew any of these, you didn't follow the rules for drawing Lewis dot structures, go back to that video and watch that one. What about chlorite? Well, chlorite again is on your polyatomic ion chart. Chloride is ClO2 minus. So what is chlorine? That has 7 valence electrons. Oxygens have 6, but I have 2 of them, so I'm going to add 12. And then I have a negative here, so what do? I add 1. That gives me 20 electrons. Now, how do I draw that? Well, I have my central atom, I have my outer atoms, my oxygens here. And so if I were following our rules, this is what I would draw. Now, if you were to actually look this up, you'll find other kinds of Lewis dot structures you can draw. But remember, we're following just the simple Lewis dot structure rules. This would be totally allowable because you followed all of the rules. We don't care about expanded octets because we're never going to deal with that. All right, so that's it for this video. If you have any questions, let me know.